Hey girls, apparently you didn't do log before, so I have to adjust the lesson. So let's start learning about logarithm function. The definition of the logarithmic function. So let's use a simple example. If I say 2 to the power of 3 equals to 8. So this 2 here, we call it the base of an exponential. And there is an equivalent way of saying exactly the same thing using the log function, which is the inverse of exponential. In other words, we use log. Now, whatever you put it under the log is also called a base. This base stays the same, no matter it's in exponential or in log function. However, what we're trying to say is 2 to the power of something equals to 8. In other words, I'm looking for the power that 2 to the power of that thing equals to the middle number in here. So I'm looking for the number that 2 to the power of that number, that is 8. So that will give you 3. So in other words, the output of the log function was the power before in exponential function. Okay, so in other words, how we read log function again, it's 2 to the power of 3 is 8. So let's do some simple example to revise your understanding in log. So let's evaluate. Let's say log base 3 of 9, that is 3 to the power of something that will give you 9. Of course, 3 to the power of 2 is 9. Okay, so let's say log of 4 of 1 on 16. So 4 to the power of what gives you 1 on 16? Remember, fraction simply means reciprocal, and reciprocal is represented by the negative power, which means 4 to the power of negative 2, my bad. 4 to the power of negative 2, that is 1 on 16. Remember, 4 to the power of 2 is 16. Negative means, the negative power means reciprocal. Okay, sometimes we even can use, let's say, one more example. 3 to the power of what gives you 1 over 27? Remember, 3 to the power of 3, that is 27. Put a negative in there, that will give you reciprocal. And sometimes question can get a little bit more complicated. For example, log base a of 4. What does that equal to? First of all, you need to take a to the power of something equals 4. It's not quite easy to imagine, but if you take the denominator as 3, that means you take a cubic root of 8. And then if you raise the power of square, that will give you 4. So in other words, it's 2 over 3. So log base 8 of 4 equals to 2 over 3, because 8 to the power of 2 over 3, that is 4. So that's the basic understanding of logarithm function. It is just simply another way of representing the exponential, but making the power as your output. Okay, so let's take a look. Some important stuff. Remember, all we're focusing on is the base of e in this whole chapter, just like what we did in exponential. So some notation. Ln is exactly the same as log base of e, where e is the natural number. in Cambridge book only, if you see this log, that means log base e, which is also means ln on your calculator. So the one on your calculator say log, it is not the same as what we got in here. It has the base of 10. And ln is exactly what you need to use for most of the occasions. Okay, so now the next bit we're going to talk about, it's called the log laws. Now this is simply another version of the index law, but log has its own version of laws. So the very first one we need is, if I have a log base, I'm going to use base e in here all the time, because that's what we will be doing later on. If I have a product inside the log, that means you can actually expand it with an addition. Oops. That is supposed to be y. So log base e of x times y is actually equals to log base e of x plus log base e of y. So this is basically the same as saying e to the power of m plus n is equals to e to the power of m times e to the power of n. Can you see that? Your power is actually added. Remember, the output of log, it's the power. Okay, this is just a reverse version of this identity in index law. And do remember, it's the power, it's the product inside and outside becomes addition. It's a very easy to make mistake. If what happened if it's a sum inside, does it equals to log x times log y? It's big mistake. This doesn't hold. Okay, if it is the sum inside of the log, you can't do anything about it. Nothing can be done. Okay, so the second version, of course, once we have the multiplication inside the log, we also have division. If it's division inside the log, outside it becomes subtraction. Okay, this is exactly the same as e to the power of m minus n, which is e to the power of m divided by e to the power of n. They are the same, just different version of saying the same thing. So part 3, log. This is one of the important ones. If we have the power of n inside, in other words, you have n of the x multiplied together inside the log, you can actually bring the n down. Not derivative, be careful. This is simply a log law. And that actually is x times x times x, n of x together, which means you can use the log law 1. That becomes log x plus log x plus log x plus log x plus log x. In other words, there are n log x adding together. So therefore, it's n of log x. Okay, these three are the very famous log law. However, there are some results we might want to consider as well. So that is the important result. I don't call it log law anymore because they are not law, they're just some result which is handy for us. Such as, no matter log base of that, of 1, that should equals to 0. And generally saying, if we have log base a of a, that is 1, because a to the power of 1 is a, and e to the power of 0 is 1. And the last one, what happens if I have 1 on a? That just gives you negative 1. Those are the very common results you might use inside the log functions. Okay, let's see some example about using the log law. Simplify. Let's say log is e 3x squared. Okay, what does that equal to? So 3x squared is 3 times x squared. So the first thing you need to do is separate it into this format. And do remember, we have the third log law. If there's anything raised to the power of n inside the log, you can bring the power down. So that becomes 2 log x. Okay, so part B. What happens if we have x plus 1 and then x times minus 2? Oops. Simply just expand it. Well, when I say expand, it means using the log law 1. Inside multiplication, outside becomes addition. Okay, what happened? We have something like x minus 5 and 3x plus 1. Something like that. How do we simplify this? Remember, anything inside the log, if it's division, outside becomes subtraction. So that is how we use the log law. Let's give you one more example. Let's say log of 12x squared y cubed. Now, using the log law, we should be able to separate individual terms, and then some of them can be further simplified using the other log law. Okay, remember the power can be bring down, but by derivative, this is just a log law. Okay, now the next one is the famous change of the base rule. Oops, change of base formula. Now, do remember our calculator only has 2 different log base. One is log base of e, one is log base of 10. So what happens if we want to evaluate other bases? Even in an approximation, we can't do it. So therefore, there is a famous change of base rule, which you do is you put any log base you want. Now I'm just using e, and you put the bigger number inside the first log and divide it by log base of e, or log base e, or whatever the smaller number, which is the original base in here. So this b is whatever number inside the beginning, and this a was the big, or was the base. Okay, so for example, here is evaluate log base 2 of, oops, 2 of 15. Well, you can't find the actual power that 2 to the power of something equals 15. All you need to do, you put log base e of 15 and log base e of 2 inside the calculator. Sorry, girls, unfortunately, I don't have a calculator with me now. So that would just be dot, 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 dot. You put this in the calculator, you should find the answer. So let's do one more. For example, log base of 4 of 125. If you want to find an approximation of that using the calculator, just log base e of 125 over log base e of 4. So do remember these two things. In calculator, LG is the LN button. I still call this log. Because that's the most common base we're going to use. Okay, so therefore that's basically all you need to know about the introduction. Not quite introduction, it's a little revision of log from year 10. So we have the basic definition, how to represent log, using this to evaluate 3 primary log laws, common results, and some simplification, and also using the change of base rule. Okay, so homework is exercise, I don't know, is it 1, 2, 3, 3A. Okay, see ya.